Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Welcome. You have found another episode of the Digital Enterprise Society podcast. Thank you so much for joining us every single week if you're a repeat listener, or if it's the first time that you have found the Digital Enterprise Society podcast. Thank you for jumping in and joining us on the journey of this show that we designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig.
Hey, hi, Tom. It's good to hear your voice, as always. And this is going to be interesting today. We're going to talk about the word digital, and in particular about integrated circuits, because it's been a lot in the news recently about the disruption being caused. There's a lot of causes, but we'll talk about that. But anyways, isn't it interesting that integrated circuits are what enabled digital enterprises and our society and all the use of computers, and yet they're a constraint, or at least that's what the news is claiming. So we're going to talk about that for a little bit today.
Awesome. Well, and today we don't have a guest, Craig. You're the guest. I'm going to interview you about kind of this whole idea of the integrated circuit shortage and how it's affecting all kinds of products, from cars to computers to Internet of Things to the and the pandemic. It's partly to blame, but I think you have a lot of other ideas of other things that are really happening around outsourcing, supply chain, and streamlining.
Well, yeah. So let's first, integrated circuits are everywhere. They're the little chips. People talk about chips all the time. And whether you've got a phone or a Fitbit or a car, there's all kinds of chips in all those devices. And a lot of times people don't remember that. The chips are just a piece of silicon that's been etched with a bunch of gates. The gates are yes and no, basically. They put millions or even billions, B with a billion, onto a one piece of silicon that's the size of a postage stamp, which is just amazing, the technologies that enabled that. Well, okay, so then the pandemic comes along, and all of a sudden we're at home, and a lot of us needed better home equipment. And so we bought a laptop or a computer or whatever, and all that stuff has chips in it too, of course.
Oh, I mean, the microphones, the cameras, everything that we're using to be able to communicate over Zoom and do everything. It's all got chips, and everything's sold out. I know, because I record several podcasts, not just ours, and everybody I interviewed was like saying, hey, what kind of equipment should I buy? Should I have a mixer board? Should I get a higher end camera? What kind of microphone do I need? And all of a sudden, you couldn't get anything for a home studio from like April through September.
And did the prices go up?
I think they did. Fortunately, I already had my studio decked out, so it didn't matter. I didn't have to buy anything new. I had lighting, I had the camera, I had everything that I needed. But probably supply and demand came into play on the cost of a lot of these things.
And we're going to come back to that point before we're done, because that's, anytime there's a supply disruption, economics will fix it. It does fix it. Money flows, people invest, and things happen, right? I think why the news cycle is blaming the pandemic was all of the disruptions that occurred at once. So if you're in a car business, you sat there and you said, holy mackerel, a year ago now, supply is way outstripping demand. We have to cancel orders. So they did. IC foundries, people making chips, they have a cycle of, a few months, right? From the time they order to the time the chip gets to the people who make the box, and then the people that make the box, it takes them another 6 months or something. But anyway, so orders got canceled. And then other orders increased, these orders for studio equipment. Well, like any kind of market, things adjusted. The foundries, so the foundries are the people that make the chips. Well, we don't have time to get into it. It's pretty amazing what they do. And they're just like big car companies, only except they make billions of things instead of millions of things. But they get really good at streamlining, and they get particularly good at aligning their supply chain. Well, with globalization the last 30 years, a lot of supply chains have been streamlined across the globe. And again, that's fine for cost efficiency when everybody's at peace and there isn't a disruption. But then all of a sudden, you get a disruption like a pandemic or even a trade war. And all of a sudden, your supply chain is less capable. And so I think what I believe is the real conundrum here is not that we don't have enough capacity on a global basis, but rather that it switched to what was on demand, and then car sales came back. and it's been kind of surprising, right? I mean, it's good for the car business, but now that all of a sudden they find out you can't make the one of the most popular pickup trucks, Ford 1F50, because you're missing a chip, and it isn't even the digital computer part. It's actually supporting chips that are not available. And when you dig into, well, why is that? Well, they're busy making chips for other things like studio equipment we talked about. So it's a couple fold. The pace at which the changes occurred outstripped the pace to be able to be flexible. And I think this is the lesson I wanted to get across to our audience is how do modeling and PLM and things like that help with the flexibility of being able to adjust to all these market forces. And they've been dramatic. And of course, here we are the spring of 21, and it's still dramatic. It's a little scary what's going on in Southern Asia at the moment with the Indian continent. So time will tell. We'll get through this too, I suspect.
Well, that kind of leads me to a question just crossed my mind. Because the pandemic has hit different areas of the world. First it hit China, then it hit Europe, then it hit the United States. Mm-hmm. Now South Asia is being hit so hard. Do you think that also plays into disrupting the supply chain? Because we do have this whole global thing that different areas getting hit at different times. Does that sort of also cause the disruption?
Yeah, absolutely. And if you're a logistics person, you do think about this. You think about, okay, how hard is it to ship in normal times? How hard is it to ship my thing from point A to point B? Even the Suez Canal a few weeks ago, right, where it was blocked by a big ocean-going container ship. Most of those goods were consumer goods, but it disrupted the supply chain. Well, supply chain experts think about this. In fact, not surprisingly, they make models. They make simulation models. Suppose the Suez Canal is blocked. What happens? Suppose Long Beach can't unload its shipping containers. What happens? Suppose aircraft can't fly and move key electronic parts around the world. What happens? And I suspect all of them have been running their models, and they probably started running them 18 months ago when the first hint of a pandemic was coming. But even your models, so they can tell you what's going to happen, the disruption. What they can't tell you is what to do about it, what to fix. I think if you were at war and you were the supply depot sergeant, the thing you always knew is you wanted multiple sources. You wanted multiple ways, which includes multiple locations. You want multiple ways to go get your part. Of course, that kind of a supply chain is more expensive. And so which do you value? Do you value resilience, or do you value cost efficiency? And of course, the truth is you value both, and it's a balance, right? And so maybe we had the balance a little out of whack. But yeah, India isn't a big, well, they have some IC foundries, but the thing that should concern many of us is they build an awful lot of vaccine. And if they can't ship it out, that'll be a whole nother logistics discussion. Will be about vaccines. We're going to keep talking about digital circuits, but something to watch. And putting up a new factory to build vaccines, like we've been listening to the story here in the United States, that doesn't happen overnight either. And it can have, errors, especially if you outsource it. They're just outsourcing has it has a couple benefits in terms of benefit to cost. It has some really serious downfalls if you don't manage the quality, or if the management team at the outsourced vendor is just not up to the game.
So, Craig, how can the digital technologies that we discuss at the Digital Enterprise Society, how can those technologies help with all this?
So models are key. And a lot of times we get confused by models. We say model, and some people are thinking, oh, a 3D model of exactly the way it'll look. Other people think of a performance model, like, okay, this is how it's going to go from 0 to 60. We already touched on a model of the supply chain, and just run a simulation that says, okay, suppose this piece of my supply chain is affected, how does it affect other parts of my product? And so I've always been, and we've talked about this in the past, I've always been impressed by what we do with computers, and building models to better understand the decisions we need to make is a key thing. In the Digital Enterprise Society, we sometimes talk about manufacturing, and we want to build a model of the plant based upon the kind of parts we're going to produce and the kind of line rates we want to achieve in order to make it a profitable business, right? So model key, we're all about models. Just keep in your mind that models can be really, really broader than just the thing we're manufacturing. It can also be the plant. It could even be the flow of material, and it should be the flow of material, whether it's raw material or a pre-assembled subsystem that gets installed into another system down the chain.
So building more capacity or more resilient capacity, it's still going to take time and an investment of money. So how much time and how much money? What's involved with upping our capacity?
So this is not my game. So everything I'm going to say next came from somebody else. but there was an interesting interview this past week with the leaders at TSMC, and so there was an article in the Wall Street Journal. Everybody's trying to get to the bottom of this story about what's it going to take. And one of the things that this gentleman pointed out, he said, well, and TSMC is based in Taiwan. It's Taiwan Semiconductor Manufacturing Corporation. They're the biggest in the world, and they have foundries all over the place, a lot of them in Asia. And interestingly enough, one of the foundries they're building is now back in the United States. It's at this point about multiple locations, right? Including not being dependent on shipping in a container across the ocean or in an aircraft. And so I would just point out to the listeners, what has happened as a result of the pandemic, this disruption, is encouraging people to say, okay, where do I want my next plant? Well, there's still an awful lot of consumers in the North American continent. There's 500 million of us. We're starting to beat the pandemic, so that's good. So there'll be demand here within a year or two for things that have ICs. So it's going to take a year or two to build a plant. It helps if you're in a climate like Phoenix where you don't have too bad storms and it's dry. But you got to do it. You got to build it. Now, in the digital world, we have models. We have a model of a plant that's in Taiwan. I'll bet you $1 that plant in Phoenix will be identical. And that's one of the things about having models is we have a proven thing. We don't have to discover it along the way. We know the thing will work. We just need to duplicate it, copy it. And as long as there's demand, the people that have the money, whether it's the investors or some funding agency, a venture capitalist bank, whatever, they will all pony up, especially with the disruptions we're seeing. The prices are starting to increase, back to economics. And, nobody really needs to get really rich over this. What people need to do is just fix the capacity. And I think capacity, you might see smaller plants. You would think that's a dichotomy, right? Why wouldn't it be a bigger plant? Oh, so you can put more of them in various places, which gets you back to resilience, right? So it'll take somewhere between 12 to 18 months. This gentleman from TSMC that was being interviewed, he said, oh, we're going to solve it in the next 6 to 8 weeks. Well, what he meant was shipping the parts out of his factory. By the time those get into products that you and I can use, at best, it's another 6 months. If it's in something like a car, it's probably another 2 years. So
it's
several
interesting.
months is the answer to your question.
It's interesting that you bring that up. I live, as you know, we always joke about, I live in Austin, Texas. And when I moved here,
you're getting one.
When I moved here 30 years ago, a big chunk of the employment and the economy of Austin was around these fabs. There was all kinds of semiconductor fabs that were here. And over the last 30 years, they've all closed for the most part because they were retooling to be involved in different things. And the new ones were all built overseas. And now all of a sudden they're coming back to Austin. It's being talked about new plants coming in.
You know, in my career, and I was in the car business, but I dealt with digital computers, the stuff that controls your car. And we would have this debate all the time, you know, where do we want it? And somebody, usually gray haired, usually in the back of the room, somebody would say, you remember the last volcano or the last earthquake? We never talked about pandemic, by the way. But the point was, you know, it's good to have another source and probably on a different continent. And I know there are supply chain experts who run big companies. They have a requirement, multi-continent. They will not buy a part from a single continent. This current IC shortage thing seems to be a victim of the lack of that kind of thinking, a lack of planning for a disaster, right?
So here on the Digital Enterprise Society podcast, we've had a lot of guests who support both integrated circuit design, fabrication, and production. Can you summarize some of the guests and what we've talked about over the last couple of years?
Well, yeah, I wanted to make it clear. When we talk about digital enterprise as if it's something unique, and certainly a lot of us come with a mechanical engineering background because that's what drove a lot of use of simulation, a lot of use of PDM leading to PLM. It was all about replacing a build it, break it mentality with use a model to make better decisions, and then even do ergonomic planning in your plants. Well, that's all human and mechanical related, largely. We had some guests that were not that, and one of the first was a gentleman from Western Digital, and we were talking to him about what was the most influential book, and he brought up a book that at least in the car companies, we were forced to go learn about. And I say forced in quotes, it was actually quite insightful. And it was all about knowing what to manage. What do you manage in your plant in terms of efficiency? And, people like to manage the efficiency of the machine when in fact you should manage the efficiency of the output of the plant. Kind of makes sense when I say it that way. So this guy, what products does Western Digital do? Well, they do memory. They do digital memory for digital stuff that ICs plug into. They have their own ICs, right? Another one was you and I one summer, so it's about 18 months ago now, we interviewed a couple people, one from Microsoft and one from Facebook. I even think we had one from Amazon. And while I get what they do, and the thing that just flabbergasted me about the use of PLM was it was their model of a plant. And this one lady we interviewed from Microsoft, she said, "Oh yeah, how do you think we stand up a server farm in somewhere else in the world so that we can continue letting you, search all your web pages that you want to search with Microsoft tools?" And it just didn't dawn on me that a cookie cutter design of a 50-acre server farm that gets put around the world, and they're standing up. I forget her quote, but it was like one a quarter or one a month. Well, those are models. They have models to do that. And so this whole resiliency of the IC fab, it'll need the same thing. And I think there's some lessons from, of all people, Amazon and Microsoft, which are kind of very different companies, but they're both doing cloud computing in spades. The IC Foundry guys could learn something from them. And then the final one that I recall that just, these guys are at the center of all this. We had a couple of them that we interviewed from ASML. ASML makes the machines that go in the foundries that lets you produce these chips at these finer and finer geometries. It really is just a 2D picture of schematic circuits that get stacked, and the way they get stacked forms a gate. But anyways, ASML, they just talked about the importance of change management, configuration management, and being able to sell these machines. They sell the machine before they ever produce it. And in fact, the final configuration occurs on the way to the plant or at the plant. And so they've got their machines with built-in resilience, right? The ability to configure them at the customer site. And so the reason I wanted to bring these three topics up, or these three kinds of customers, is just to make it clear. Oh, we in the Digital Enterprise Society, we'll be at the center of making IC fabs more resilient, and even this right sizing them. And so maybe having 10 that can do 10 units rather than one that can do 100 units, some combination there. It's really in the 60 Minutes special this past week about there used to be 40 fabrication foundries, the people that melt the silicon down, cut it into wafers, and then produce it. And there's some cool pictures on the show that people can look up. But we're down to like 3 instead of 40. And your point about the location, there used to be in places like Austin and Houston and Silicon Valley, and then it all moved overseas. Well, I think the better number is around 10, and certainly not 3. And everybody listening, this is what happens, right? Look at the car business 30 years ago in the United States and North America. We were down to 3 of us, right? 3 big ones. How many do we have today? It's over 11, 12. And so my lesson for everybody is supply chains are like this. They will spread back out to get to this place where resilience and capacity and economics are all balanced. And you notice in the way the car business works now, we each have our own supply chains, and they're maybe not as big as they once were because we got a little smaller volume, but they're still diverse, meaning flexible. And I think flexibility will become the new measure for some, which is good, by the way, some MBA schools to say, okay, we talked about cost efficiency and we talked about outsourcing overseas to low cost things. Let's talk about instead resilience to the unknown, like a pandemic. And when they get to that discussion, all of a sudden, location of a foundry and how many you have, the economics will change back the other way.
So you kind of alluded to this, but can digital engineering help IC design and fabrication even more as we make these transitions?
It should, but it's really different. This is something I've been researching recently about. The evolution of mechanical engineering was to replace expensive, long-to-do prototype cycles, these build and break cycles. When we went to the moon all those years ago now, we did a lot of modeling, but modeling was done by really expert specialists, right? And even in the beginning of mechanical modeling, you had a similar kind of thing. Somebody that knew about fracture dynamics in metal, or how metals would adjust to dynamic controls and loads and so on. What's the electronic world, the gates that are in your chips, it's had the benefit of something completely different, which is this Moore's Law phenomenon. And to remind everybody what that really is one of the inventors at Intel, he said, what we're noticing is every 18 months, the chips are twice as fast, half the cost, and we don't see that ever stopping. And we've been living that dream for over 40 years now. So the foundries because they're the ones that can shrink the geometries and make the chips more and more dense. So the foundries, not prototype cycles in mechanical engineering, but the foundry of the technology to put into a digital part, it's what really drove the game. And so when you ask this question, how can the digital enterprise societies help, or what we do in digital engineering, first accept that this is really different, and then ask the question, well, when will electronic engineering have some similar challenges that mechanical engineering had, right? I think it's coming. There have been lots of discussions about we're down to, tens of atoms wide in the traces, and so we're in really, really small geometries. We got, in some cases, billions of gates on a chip, but someday we're going to run out of space. Well, it's generally been 2D, two-dimensional, and a few layers. So 3D ICs is a very interesting topic these days. So imagine stacking them, or better yet, imagine turning some on their edge and some of them horizontal, and then the interconnect between them becomes key. Well, what are you interconnecting? You're interconnecting signals, ones and zeros, and you're interconnecting power. Well, anytime you can interconnect power, you're starting to create interferences, electromagnetic interferences, even heat problems, right? And so I think where digital engineering technologies, especially the modeling side, is going to help is how do we package into 3 dimensions instead of just 2? And who will drive that investment? Oh, it'll be the foundries, because they're the ones that hold in the digital world, the building of chips, building of integrated circuits. They're the ones that really hold the keys to the kingdom. The additional thing is we've talked about IoT, right? Internet of Things. So you connect your factory with a sensor and you put it on a network, and now it can communicate all the time to you. This is great. Well, there'll be more and more of that. And we'll be integrating sensors into the IC directly. We'll even be doing some computing at the sensor. Some people have coined that edge computing, not to be confused with the browser, but the point is you're doing processing at the sensor, not back in the central computer. Well, in order to do that all really well, you'll need digital modeling tools to start to model about, well, where's the data move? How's the data move? And so flow of material, we talked about that in a plant. Well, now imagine flow of data through a series of machines. Some of them are artificial intelligence, and how do you figure that all out? So I see a very big growth in digital engineering being used for data science, being used for sensor placement. And I think the foundries will be embracing the tried and true CAE vendors, simulation vendors, because that's how they certify that the chip design, and I got one last point for you, the chip design is worthy of putting in their very expensive, very valuable foundry, which, by the way, we don't have enough of at the moment. Okay, last point about chip design. All innovation comes from people coming up with new ideas, sometimes trying them out, sometimes there's a proof, sometimes there's not, sometimes they're just taking a bet, right? Some of the innovators out there, they just take a bet and they hope it'll work, right? Well, if you're a foundry and there's already not enough of your capacity to go around, how are you going to qualify a customer? Usually customers qualify suppliers, but I think in this case, the foundry is going to qualify the requesting customer to say, oh, am I worthy of putting some of my capacity on your chip design? Well, you're going to demand to see simulation results, performance results. How do I know that digital design is going to be an award-winning product, or at least a capable product that might have a chance of winning awards? So I think there's more and more designers. I think around the world, people are realizing you can do this stuff from home. And so I think digital design will continue to explode because there's a market for it. And who builds it will get adjusted a little bit, thanks to this lesson from the pandemic. And digital engineering, what we all talk about all the time, from simulation to even we've talked to some people about systems engineering. Oh, there's systems engineering challenges in spades about all these things, whether it's the layout of your supply chain or just how flexible do you make it so you can change it in the field. So, yep, we'll help, and it'll help in different ways than mechanical engineering did. That's the thing that people need to spend a little energy thinking about.
So, Craig, how long do you think it is until we manage this pandemic globally and all the problems that are being caused that we just talked about? And how long till we improve the IC fabrication capacity so that it's not a constraint on all these products that, hey, we want to go out and buy them. We love these products. How long do you think we get back to normal?
Oh, Tom, I'm afraid I can't answer normal relative to the pandemic. Well, I just can't. The surge happening now in other parts of the world, heck, even the surge here where I live that occurred over the past couple of months, part of that is just the way biology works, and we don't really control it. Best we can do is learn to cope with it. But on the chip side, I think pretty quickly the guys running the integrated circuit business, the foundries especially, they're adjusting. There's a plant going into Texas. There's another plant going into Arizona. Politicians are waking up and realizing, oh, maybe I want a plant in my backyard. Heck, General Motors has a mothballed plant in Indiana. We talked about that ago when we had Mark on the phone. And so I'm confident that the adjustment of foundry space, well, that'll happen over just like the president asking us to build ventilators, and before you know it, some ventilators are being built in some of these places. So that'll get fixed. How fast can we deal with the pandemic? Everybody just value resilience. I think we're going to need to be resilient, because I don't know that we can predict where the next wave front's going to come. Stay aware and be aware of the variants. The variants are kind of scary. You know what? The guys at CDC and NIH and all the rest, they're running models. Some of the best universities in the country are running models, and some of those models are sobering. So, a few variants, and we've experienced a couple of them, right? But a few more like that, we're going to be dealing with COVID for a few decades, I'm afraid. Rest of my lifetime. That's what it feels like.
I didn't want to hear that. I hate to end on that. So what's the last piece of advice you have?
Well, so I think I'd like to, I've talked in the past with folks about building bridges and understanding motivation. I'm a systems guy at heart, and so I like to think about these things. And I think the thing that surprised me about the disruption in the supply chain, I did not appreciate. We'd gone from 40 some odd vendors that are IC foundries. I'm talking about companies now, not locations, down to just a few. In your line of work, all of you, if you're seeing you're streamlining your supply chain that far, you might just want to build a model about what could go wrong if one of those breaks, right? And I think if I were still in the business day to day of running those kind of choices, I think resilience would be a higher priority than cost efficiency. And I get shareholders need to get their profits. I'm not arguing that. I'm just saying right now the guys who are more resilient look a little smarter.
Awesome. Well, Craig, thank you so much for this conversation, and thank you to everybody who listened. I hope that you enjoyed today's chat. And Craig and I would like to hear from you about your thoughts about this topic or any other topic. If you've got something you think we need to be addressing right here on the Digital Enterprise Society podcast, let us know. Right, Craig? We want to hear from them.
Yeah, there's a lot of interesting things. I sometimes am frustrated. The words digital engineering are so broad. It can mean so many things. And I hope you guys enjoyed a bit of the pun today. We're talking about digital engineering for digital parts, which enabled digital engineering. But anyways, maybe it's just all about making good decisions with better insights. And you get better insights when you model stuff. And there's a professor that gets quoted a lot. I don't remember his name, frankly, but he would start his lecture, all models are bad. Some are useful. What he was really getting at was that models, when you get data, when you collect more data, so more IoT, when you collect more data, you learn more. And when you learn more, you adjust your models so they're more accurate. Look at the weather models, right? Your weather forecast changes dramatically day in and day out, a couple of days out. But a couple hours out, it's pretty accurate. Well, that's just because we're getting better and better at understanding. So the same thing happens with all digital enterprise technologies, is better models will lead us to better decisions. And when we get surprised, like the pandemic, well, then we'll adjust our models so that this doesn't happen again. And that's how we use digital engineering, as well as all digital technologies associated with it. And I'm sure, Tom, you asked me about when will we start buying stuff again? The at least in the North America, the economy is going to be phenomenal for the next 18 months. There's pent up demand. There's available money. And I'm not talking about the government. I'm talking about you and I as individuals, right? We haven't been spending for a year or so. So, it's going to be really, really rosy. And I hope we work on resilience as well as everything else while we're at it.
All right. Awesome. And thank you to everybody for joining us here. We want you to join us every single week for more thoughts, ideas, and information in and around product lifecycle management. And remember, the Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you heard here today at digitalenterprisesociety.org. Join us again next week for more Connection Without Boundaries and Creation Without Limits.